Hello, can you hear me? Yeah, I hear myself, so that's all right. Um, good afternoon, everyone. My name is Wojciech Teclaw. I work for SINTEF, so the Research Institute in Norway. And today I'd like you to present the construction phase digital twin on behalf of BIMprove project. Therefore, I'll start with agenda. So I'll describe you what's the BIMprove about and what are the stakeholders participating in the project. The next point will be about digital twin definition itself because it's quite blurry nowadays. Next, I'll move forward to requirements for digital twin implementation and how the BIMprove project approaches to the concept of digital twin during a construction phase. So the first point are our partners. So there is not like one big research institute who owns the whole knowledge, but the knowledge is spread across the whole Europe. So we may see that we have 5 European countries participating in projects, different research institutes, different construction companies, standardization institute, DIN from Germany. So also Katenda, who might know from this event. So first, I'd like to propose you the BIMprove solution. So we provided open source solution. So all this knowledge which currently I'm presenting is open source through dissemination materials and GitHub projects. So feel free to use it. And we proposed spreading the BIM digital twin into separate layers and just combine them. So, but first, what's the digital twin about? Maybe you heard more about BIM concept, which is right now it's more standardized with every year. But how about digital twin? What's the digital twin about? So this concept was originally proposed in 2003 by Michael Greaves, the professor from USA, who defined that digital twin concept might rely on 3 basic objects. So physical object, its digital representation, and the connectivity between them. To be more precise, the bidirectional connectivity between instances. So here we have a digital model, so equivalent of BIM model. If we have our virtual model and our physical asset, they don't communicate each other. Here we have digital shadow. So for example, IoT devices. We are sending streaming information directly to our virtual model, virtual replica. And here we have digital twin. So our virtual instance, our virtual object is able to modify the state of physical asset. And if we have a look at different research papers, different marketing materials, we may find different definitions. Digital twin concept, digital twin model, digital twin prototype, instance, framework, platform, ecosystem, and many more. So it may be blurry for you, but basically the concept is based on these 3 basic assumptions. And if I would ask you about digital twin, probably most of you would answer that digital twin is something what I found useful for operational phase of the life cycle of an object. But to provide a good informational input for this object, we need some geometrical data, some location orientation, some non-geometrical data like properties, classification, some connectivity between different systems, relation between spaces, how the space or our room is located in our building. And of course, during the construction phase, we are gathering many useful information like warranty, information, suppliers, manufacturers, serial numbers, and many more. And the most important, we are getting information about the differences between design and building state. So therefore, majority of information you're able to gather during construction phase. But we have our construction phase mostly is quite specific. Let's say we have a typical day on the construction site where we have workers working with their tasks, and just an escalator came to our construction site. It started digging a hole in the ground and it disappeared. After it, we got a human who just came and he wasn't aware of this hole, so he fell in. And that simple accident could be prevented by putting a just simple barrier. And accidents like that occurs every day. Of course, it's much more rare because of the safety requirements. We put much more effort to the safety of the construction, but we lose a little bit of productivity because of that if we compare to the 1960s. So therefore, digital twin proposed by BIMprove focusing on not operational phase, but construction phase, how to gather, transfer, convert, use this information, analyze them, and convert into some useful outputs. So we are using survey data, BIM, historical data from time and cost planning, context-related information. Where are our workers located on our construction site during everyday works, and of course different input devices. Then we process this data, combine it, and based on some analysis, we are able to provide an outputs like BIMprove, BIM vehicle, BIM anywhere, BIM site office, which I'll show you in the end of the presentation. The whole project focused on 3 basic use cases. So fire protection, fall from height, and scheduling. So if we have our construction schedule, it depends on multiple factors. It's not only like we plant here will be our supplier, and it is perfectly in that second, because different situations occurs on construction site. So for example, fire. I work in Norway, so on construction sites we have some heaters for workers in winter, and if they are put too close to flammable materials, we may get fire. Not even directly in that moment, but after 2, 3, 4, 5 hours after the day ends. Heat-related tasks like welding. So I'll show you how do we approach to this topic. And fall from height is much more obvious, so lack of safety barrier fence, horizontal, vertical safety nets, fall protection equipment like a lifeline, and bad usage of scaffolding or ladder. So as I said, I'm focusing basically on these 2 use cases. So here we have data gathering process. So somehow we have to supply the information to our model. So we decided to use unmanned ground vehicles and UAVs to capture different types of data. So we are not only capturing point cloud and just regular image, but also we added to this data representation and thermal images gathered during construction process. Yeah, so also drone was designed and manufactured by us to be modified. It has Raspberry Pi inside, so it's able to stream the data and analyze constantly. Yeah, and we have some results of our data. So we captured some data, so we can do some processing of it. So it's not so easy to capture a good quality point cloud because it captures the whole information like temporary structures, material storage, etc. Therefore, we are doing some segmentations comparing this information to BIM model, and we are able to to compare this information with our model, so clean the data. And here we have only points which were mapped with our BIM model. In second, you will see how it looks like. Yeah. Just a second. Yeah. So here we have fully captured point cloud, which was provided by robots. And if we turn it off, we may project this information to our BIM model and, for example, see how this information, it needs a second, how this information is combined with our IFC representation of the building. Okay, so we have different models. Of course, this is quite early stage of design, so we are able to compare it to, of course, structural model, which in the majority of cases comes as the first domain. So we have this model aligned with our IFC building. And of course, as I mentioned, we're gathering plenty of thermal images, but of course, this particular image isn't super interesting for us. We may maybe check the temperature of our employees, but it's not super related. But such work as it is here, welding, is very related to our process. So we take this data, and of course we got some images, but do we have some human who's sitting all the day long and labeling the data? No, of course no. We were using YOLO algorithm. By saying YOLO, I mean you only look once, not you only live once, because the original concept was dedicated for detecting like everyday objects. So we had to retrain the AI algorithm, enriching this information by our pictures, achieving around 95% accuracy. And we are able to combine this knowledge with, for example, barriers, garbage, safety fence, and any other elements. Later, the data was represented in form of course, some set data structures. We decided to use semantic representation, so we designed an ontology dedicated for representation and risk on construction site. And based on captured information, we were combining this knowledge with different risk, which was predicted. And the risk was combined with risk zone, where we had our employees working constantly. And if our risk was above intolerable level, we could warn our employees by vibrating their helmets, because data anonymization, we are living in RODO era, so it's quite a severe topic. And here is how this combined knowledge might be used also in VR. So we have 3 participants in some checking of our construction site, but instead of this particular case is in Madrid. So instead of going directly to construction site, you may perform the whole check from construction office. So we see our colleagues going into some floor, and they are checking if everything is in place. We see also point cloud included in this model, and for example, there is some railing missing here, so we can do BCF and connect this BCF with our workers in a particular zone and notify them that there is some information, there is a new task to make in this space. Okay, we can continue. And for example, here I think there is missing barrier. So we are able to draw how our safety barrier should look like. Yeah, this is like from this point to another. And this task is automatically assigned to our workers on the construction site. Of course, if we have all our information, like for example, here we have a waypoint which goes to the exit, so we can use it as an escape route, or use it as a trajectory for a drone, or like for the staircase is a little bit easier for drone than for ground vehicle. And this is done of their task. So they have different issues, safety issues, which are combined with people. And in bottom right picture, we see people just doing their work in the construction office, and we will see that this model is combined with real construction site, which is just behind a fence. Yeah, so we have people working. Two people were doing inspection in VR, and one was just using a regular computer with a display. Yeah, we are zooming out. And exactly the same construction site we see through the window. So the next steps of the project is doing certification. We are investigating different types of robots like Boston Dynamics, Robotnik robots, and we just gathered some knowledge with our partners, and we want to certify construction site if they are like digital twin ready, because despite having a BIM model, it's not super easy just to convert it and provide the whole knowledge, which will be able to integrate with our workers, also including different regulations according to standardization, safety, and of course data anonymization. So thank you for your attention. All the materials, as I mentioned, are publicly available, so feel free to use it in your further projects. If you have any questions, we can have just a chat on the side.